Hello everybody, as promised, I am going to do a quick video on cylinders and cones. But before we do, we need to take a step back in time to just remind ourselves about prisms. When you find the volume of a rectangular prism, you can do the length times the width times the height. You've been doing this since elementary school. The other way to look at that is you can do base, the area of the base, times the height. Now that would just be length times width times height. But all three measurements together, when you multiply them out, will give you the volume. We also learned that a rectangular prism is half of a triangular prism is half of a rectangular prism. So if you want to find the volume of a triangular prism, you want to just do everything you would do for a rectangular prism, but divide by 2. That's because a triangle is half of a rectangle. So a triangle has that triangular base. See that? The triangular base, which is half of your rectangle or square. Okay? So rectangular prisms and triangular prisms we've already done. All right, this is a little bit of 6th grade math and a review in the beginning of 7th grade math. This helps set the stage for cylinders. Now, we went over this in our Desmos. So if you go in their very first one, Unit 5, Lesson 11 and 12, and you flip over, we talked a little bit about this. So we have this page where we went over the cylinders and we talked a little bit about them and we matched them up, okay? So now moving into our new learning, which is our cones and our cylinders, we're going to slide this over and we're going to talk a little bit about cylinders. Cylinders are prisms, okay? So just like a rectangular prism, length times width times height, or area of the base times height, area of the base times height, you're going to do the exact same thing for the cylinder. But you got to be careful because the base of a cylinder is a circle. Okay, so this goes back to our notes, and I have our notes here from Math 7 Unit 3 when we talked about circles. So we had a whole lesson on circles where we talked about diameter, radius. Radius is half of the diameter. Diameter is twice the radius. And we also went over how to find area of a circle. We also did circumference, but for our volume, we just need the area because we want the area or the whole entire bottom of our cylinder, which would be the area of a circle. You need radius for that. So when we're working with our cylinders, okay, if we know the radius of our cylinder and we know the height, then we can find the volume. So again, you need the area of a circle, which is just radius squared times pi. And then to find the volume, we just multiply that by height, just like we do for a rectangular prism. Area of the base times height, or length times width times height. The area of the base of a rectangle is just length times width, but the area of the base of a cylinder is pi r squared, or radius squared times pi. Okay? All right. So when we do this, let's say we have a radius of 5 and we have a height of 8. Okay, we're going to try just a simple one here, and then we're going to go over a few in the Desmos. Now, we did a whole Desmos on this. Okay, a whole Desmos. We reviewed how to find area of a circle. We did a bunch of practice problems on how to find volume of a cylinder. So if you're still having a little trouble, pop into the Desmos and go through and try those out. All right, I'm going to do just a quick sample problem, and then we're going to go in and look at the examples that we did in class. The radius is 5, so that's this part right here, and the height is 8. So we know we need the area of the circle. So we need the base of the circle. That is just radius squared times pi. Now we're just going to leave pi as pi because we can use 3.14, but we're going to put it in terms of pi. We're not going to multiply it out. Even though we know it's about 3.14, pi is always an approximation because it's irrational. So I'm going to do 5 squared, which is not 5 times 2. That's 5 times 5. Some of you are still messing that up. This is an exponent, 5 to the second power. You're multiplying 5 times 5, not 5 times 2. And then I'm going to leave pi here by itself. I'm just going to leave it here. Remember, this is the commutative property. We're multiplying, so the order doesn't matter. Like length times width times height, height times length times width, width times height times length. It doesn't matter. It's the commutative property. So I'm going to kind of save pi to the end. I'm going to save him for the end. Okay? All right, so I have times 8. So this would be 25 times 8. And that's going to be 200. So my volume can be expressed as 200 pi. And we can leave it like that unless the directions tell us to use 3.14 as pi. Then we're going to multiply it out. Now, the beauty of Desmos is that when you come in here and you do your work in Desmos, you can actually just pop open a calculator, 5 squared. Okay, so I have my radius squared. I have my height. So I know my volume is 200 times pi. Now watch, I can do times pi, find the pi button, and that would be 628 and then the decimal. I could do 5 to the second power times 8 times 3.14, which is the approximation of pi, and then I get a nice easy whole number. Or I could just say 200 pi. And Desmos will automatically do the math for you. So you can leave it as 200 pi. 200 pi is just multiplying these two and just leaving pi at the end. Okay? All right, so let's try what happens when we have the diameter. So sometimes they will give you the diameter. So if they give you the diameter, let's say the diameter is 6 and the height is 5. Okay, I don't need the diameter. I need radius squared times height times pi, but we're going to leave pi at the end, right? We're going to do that one last. So I need my radius squared. I don't want diameter. I want radius. I need half of this because radius is half of the diameter. So I need 3 squared times 5. Okay? 3 squared times 5, 3 times 3. It's not 6, it's 9. 9 times 5, that is 45. And I can leave it in terms of pi. So I could just say my volume is 45 pi. Again, popping it over to the calculator. I know my radius, diameter is 6, so cut it in half. 3 squared times 5. Radius squared times height, 45. And then don't forget the pi at the end. We're leaving the pi to the end. We're saving that last step to the end because we can just put our answer in a form of pi. So we can use the pi symbol in the calculator, or we can just do 45 pi. See that? And it's going to give us the same answer. That is because pi is irrational. And if we all use a different version of pi, 3.14 or the pi button, or even the fraction 22/7 is also a version of pi, we're going to get slightly different answers depending on which one we use. So sometimes we just leave it in the form of pi, because this number, the 45, we all can get. We can all get 45. We can all get 200 because that is physical math. Those are rational numbers. 25 times 8 is 200. But pi is kind of a wild card, right? Okay. So this is how to do cylinders. Now, sometimes you're going to get the volume, and you're going to have to find either the radius or the height. So we did a few of those in class today. So if I give you the volume, so let's say the volume is 36 pi, okay, and I say the height is 4, so I need to know what the radius is, okay? So I know that radius squared times the height times pi will give me my volume, okay? I know that. I'm going to save pi to the end because see, pi is already here, so I don't need to worry about that. See, I'm just going to kind of cross it off. It's still there, but I don't really need it for my calculations. All I need is radius squared times height. So I know the volume is 36. I know the height is 4. So I'm just going to plug in what I got. I don't know this, but I do know this, and I do know the volume. Notice I just took pi out for a few minutes. Okay, so what times 4 is 36? Well, 9 times 4 is 36. A lot of you think the answer is 9, but this is not the answer. What squared is 9? What squared is 9? So I don't want to put 9 because 9 is what this is, r squared. This is r squared. I need that number. It's 3, right? 3 times 3. Now, I showed you on the calculator that in order to find what the number is squared, you can use the square root button. So square root of 9 is the inverse of 3 squared. Okay? So this is another nice little calculating tool that you can use. Let's say the answer was 49. 49. What times what is 49? What is the square root of 49? It's 7. 7 squared is 49. And we're going to do a little bit more with this later in the unit. All right, so now I know that my radius is 3. I just figured it out because 3 times 3 is 9. So my radius is 3. So watch what I'm going to do. I'm going to go back into the original calculation and make sure that I have my math correct. Radius squared times height times pi is equal to 36 pi. Now again, I don't need to worry about the pi part. That part is sort of the constant, so I don't have to worry. But I do want to check to make sure that r squared times height is 36. So 3 squared times 4, 9 times 4. Check. It works. Okay? So I know I did my calculations correct. Okay, so let's take a look at lessons 13 and 14 practice. We did this together. Okay? We went over this together. We did a review of area of a circle, okay? Radius squared, 4 squared, that would be 16, okay? 16 squared would be the radius of that circle. Radius of this circle is 10, so 10 squared, that would be 100, and 100 times pi, see there's no 100 pi down here, but there is approximately 314 because 100 times pi would be about 314. And then circle C has a diameter of 16. So diameter of 16 means we have a radius of 8. And 8 squared is 64. Okay? And then this one would be circumference. We're not doing circumference right now, so that's why that one's at the bottom.